In this video, I'm going to walk through the creation of an ER model. If we go to the class website, click on the schedule, and look at the exercise under ER models, the movie rental ER exercise. We'll go ahead and go through this. So an entity relationship model, or an ER model, is a kind of conceptual model in database design. Okay. What it's used for is to take a somewhat formal specification of a database modeling problem from a customer and put it into a precise format that doesn't have any implementation details in it, so it can be it's precise enough so that the database developer can take the conceptual model and go create an implementation schema from it, but it's still at a high enough level that that non-technical people can understand it. Okay, so to create an ER model, we'll look at a specification like this and look at all especially the nouns and the verbs. So the major nouns, which I've actually highlighted here for simplicity, are going to become the entity types. Other nouns will be attributes of those entity types. And then many of the verbs will become relationship types. Okay, so let's go ahead and get started and model the store and staff. Okay, so up here, so store is going to be an entity type. So we put store in a rectangular box, and the specification said that a store has a name, as an attribute. And attributes are enclosed in ovals and connected to their entity types with a line. A store has a name and an address. Now, address will make it a compound type, so that means that it's actually composed of other attributes, such as street, city, state, and zip. All right? So name is an atomic attribute. It can't be subdivided anymore. And address is a composite attribute. It's actually composed of street, city, state, and zip. All right? Now, the problem specification said that the name attribute is unique. That makes the name attribute a key attribute. And so we'll underline name. Now, uniqueness means that no two store entity instances, can have the same name. All right. A staff member has a first name, a last name, an address, and an email. So we'll go ahead and put staff over here. So first name, last, and we'll just put address. We don't have to put everything down. Okay. Now, every strong entity, we'll talk about weak entities in a minute, but every strong entity has to have a key. And that key could be a single attribute, or it could just be all the attributes. If you don't specify any particular attributes to be the key, then all the attributes are a key. And in the case of staff, let's go ahead and just say that the first and last name are unique. So to actually do that, now, if we just underlined both of these and said first and last, then those are two independent keys. That means that no two staff members have the same first name, and no two staff members have the same last name. And that's not actually what we want. What we want to express here is that the combination of first and last name is unique. So we'll need to erase this. And change it to a compound attribute. All right, so name, which has components first and last. And then we underline name. And so this is an attribute, a compound or composite attribute, which is a key attribute of staff. All right. Now, we'll get more interesting here. Okay, get more interesting here. A store employs at least one staff, and a staff must work at a store. Okay, so store employs, we'll put employs over here. So this is a relationship. Relationships between entities have names, and they're enclosed in diamonds. And there are lines connecting the relationships to the entity types that they relate. All right. So we said that a store, and there are two kinds of structural constraints on relationships. The first one is a participation constraint. So we said that a store must employ at least one staff member. So to express that fact, we'll put a double line between store and the employees relationship. And that means that every store must participate in the employees relationship. All right. Now, the specification also said that a staff member must be employed at a store. So we'll put a double line there. So now we have total participation of staff in the employees relationship and total participation of store in the employees relationship. Now, specification said that a store has at least one staff member. It could have more. So that is the second kind of, that's part of the second kind of structural constraint on relationships, which is called the cardinality constraint. Cardinality is number. So the way I like to think of it is if one store can have many staff members, then as the store looks at staff, they see many staff. All right. So from store to staff, you put N on the staff side. Now, a particular staff member, looking back at the specification, can work at only one store. So when the staff looks at the store, staff member sees one store. And so this is a 1 to N relationship, or 1 to many relationship between store and staff. Or we could say many to 1 from staff to store. All right? Okay. A store is managed by one staff. So you can have multiple relationship types between entity types. So we have an employees relationship. We can also make a manages relationship, all right, between store and staff. And here we'll say that every store has to have a manager, but clearly not every staff member can be a manager, all right? So we have a total participation constraint between store and manages, and we call this a partial participation constraint between staff and manages. And one store has one manager. All right. And that pretty much finishes up our relationships between store and staff. Now let's look at film and actor and so on. Okay, a film has a title, release year, a rating, a rental rate, and a rental duration. I'm not going to put all those down, but so let's go ahead and put film out here. So film has a title, and so it's a title, year, a bunch of other stuff. We'll put rental duration. Yeah, getting kind of messy. Sorry about that. Okay, and we'll just say that the combination of these attributes are its key. All right. Yeah, let's just say the title is. Okay. So the film's title is unique, and so that's a film. Actor has a name, birth date, set of specialties, for example, comedy and action. All right. So let's put actor down here. So actor has a name, let's say that's unique and stop there, and a set of specialties. Now, because an actor can have many different specialties, we'll make the oval for that attribute a double circle, which makes that a multi-valued attribute. So if you were going to list out a particular actor, then it might be something like the name, Rock, and a set of specialties, comedy, action, for example. And so a particular instance of actor might look something like this. And specialties is multi-valued, so we would write that with the curly braces there. Okay. And there's a more detailed notion in the book where you actually put the attribute name and then the value in parentheses, but it's good enough to demonstrate for now. Okay, so an actor can appear in we'll just put appears. An actor can appear in many films and a film can have many actors. So we put N to M to express a many-to-many relationship. Now, here's a place where you can sort of make some decisions. So, does a film have to have an actor, and does an actor have to appear in any film? Well, let's go from actor to film first. So you can have actors that don't appear in films. You can have actors that only appear on TV, or you can have actors that aren't actually actors and they're just trying to break into the business. Maybe they have an agent and so on. And so we would probably keep this constraint, the participation structural constraint between actor and appears in a film, as a partial participation constraint. Now, for a film, we could, maybe it's a narrated film or something like that. Maybe it's a silent film with nothing but imagery. Or we could say that a film has to have an actor. in which case we would put the double line. That would be something that you would talk to your customers about, to ask them what the rules of the domain are. All right. Now, I'm going to stop going back and forth between the specification. We also have an inventory. All right. So, inventory, we'll say that an inventory has an ID that is unique within the store. All right. And we'll say that the inventory is for a particular film at a particular store. All right. Every item of inventory. But that in order to fully identify a piece of inventory, you need to know what film it is and what store is located at. All right. So that means we can't uniquely identify inventory without one or more identifying strong entities. And so we'll put inventory in a double-lined box, which makes it a weak entity. All right. So inventory has to have, let's see, we'll just say at store, and inventory of a particular film. Now, the participation constraints here, notice that for inventory, so these double diamonds, double-lined diamonds here, mean that this is an identifying relationship of the weak entity to a strong entity. All right. And because you have to have that relationship between the weak entity and the strong entities, the participation constraint with the identifying relationships must be total. All right. But we can say that a store may not have any inventory, and that a film might not actually be in inventory at any of the movie rental stores. All right. Now, a particular item of inventory, looking at the store, is only going to be at one store, but a store will probably have many items of inventory. A particular item of inventory is only for one film, but one film might have many copies in inventory at various stores. And now the combination of the inventory ID and the title of the film, because that's the key of the film, and the name of the store, because that's a key of the store, uniquely identifies a particular piece of inventory. All right. And since this ID is part of that ID, it's not unique amongst all inventory items. It's only unique within a particular store. We call this a partial key, and we would underline it with a dash. All right. Now, for me in this class, you can underline that with a solid line because it's kind of hard to get drawing tools to do a dashed underline, and I'll know that because it's an attribute of a weak entity, that it's not an actual key in the same sense that these keys of strong entities are. Okay. So now we have inventory. Now let's model customer. So there are lots of so we could have a relationship between customer and store, um, but um, but I'm just going to focus on a relationship that teaches us some new things. So a customer rents a film, right? But they rent something from inventory. So let's say that there is a rents relationship between customer and inventory. Okay, so many items of inventory could be rented by many customers, and a single customer, a single item of inventory could be rented by many different customers, and a single customer could rent many different inventory items. Now, attributes or relationships rather can have attributes themselves. So you would rent a particular instance of a rental relationship would happen on a particular date, for example. And if we follow this chain up to film, every film has a rental duration, which means that uh, given the film that we are renting from inventory and the date we did the rental, we could derive a due date. I'll just put due. And a derived attribute is enclosed in a dashed oval. All right. And we can stop there. We could put payment information. There's all kinds of additional information we could put here, but at this point we have covered all of the basic elements of an ER diagram. All right, we have our strong entities: store, staff, customer, film, and actor. We have we have attributes. We have atomic attributes. We have composite attributes. We have multi-valued attributes. We have relationships with total participation constraints and partial participation constraints. We have cardinality constraints like one to many, one to one, and many to many. Um, and we have weak entities. Weak entities means a weak entity doesn't have its own independent key. It can have a partial key, but it needs an identifying relationship with one or more strong entities. All right? And that is the gist of ER models. In the next lesson, we will go over enhanced entity relationship models, or EER models, which add the ability to model um, uh, subclass relationships.